Hey everyone, welcome back to the lab. Today's activity is the identification of an unknown. It's a volatile liquid. We are going to evaporate this liquid and we're going to collect the vapor and we're going to find the molar mass of the vapor. To do that, we will simply use the ideal gas law equation. We're going to solve for the number of moles. And once we have that, we will be able to find the molar mass of the unknown because we will calculate the grams of vapor that was in the flask. So let's begin. Okay, so onward we go. In this activity, we're going to do the evaporation of the unknown volatile liquid in this 125 milliliter flask. We're going to cover it with the foil, rubber band, and we're going to evaporate this in the water bath right here. So first let's begin by getting the mass of the flask, 9382. And we will also add the rubber band and the foil, 9577. Perfect. So we are going to measure 2 milliliters of the unknown in the graduated cylinder here. We're going to pour this into the flask. We're going to cover the flask with the foil. We're going to secure the foil. And we're going to, using a pin, poke a little hole in the foil, very small. And this is so that, because we have 2 milliliters of liquid in here, so it's going to more than fill up this flask. So we're going to evaporate the liquid, and the excess will leave the flask through the hole. And the hole is also there to so that we know that the pressure inside the flask will be the same as the atmospheric pressure. Given that they're open, that the flask is open to the atmosphere, the pressure of the vapor inside the flask is going to be equal to the atmospheric pressure outside of the flask. So we are at 80 degrees right now, the temperature of the water, and the lab temperature is 19.8. So we're going to record this 19.8 value. And we will also need the atmospheric pressure in the lab, which is going to be the same as the atmospheric pressure in the flask. So now we wait until all of the liquid inside the flask has disappeared. And this is very important. There can't be any liquid left in the flask. So we want to make sure that all of the liquid has evaporated and the vapor of the liquid's vapor, the gas, is going to fill the entire flask. And then what we're going to do is we're going to cool down the flask rapidly so that all of the vapor inside will condensate, and we will know, we will be able to measure the mass of the vapor, now liquid, that was in the flask. So let's wait until it's all evaporated. So after a few minutes in the boiling water, I would say about 5 minutes, the liquid inside is completely evaporated. And then we've waited a little bit longer so that we can have the temperature of the of the gas inside the flask, we can say that is equal to the temperature of the boiling water. As you can see, the flask is just about completely submerged in there. So we have, we need this information because we're going to use the ideal gas law to determine the number of moles of vapor that is in here. So we need the pressure, the volume, the gas, the constant, which is fine, and the temperature. So the temperature in here, right, we have, we're reading at 101, excuse me, 101.7. And the atmospheric pressure we will get in just a minute. So what we need now is to quickly take the flask out and cool it in a water bath, room temperature, so that the vapor that is inside the flask can condensate back to liquid form. We're going to let this cool down for a few minutes. So the mass of our flask and the tiny bit, you can see the liquid at the bottom of the flask here. So this liquid is the condensed vapor that filled up the flask. So our mass is 95.97. 95.97. And which gives us exactly 0.2 grams of vapor that was inside the flask. Now, we need to know the exact volume of the flask. And to do that, we're simply going to fill it completely to the top with water and then measure the mass of the flask again. At the very beginning, if you remember, we measured the mass of the empty Erlenmeyer flask. So now we're going to fill it with water and we'll see how much, the exact volume. Now the mass of the flask, completely filled with water, 252.86. So here's our data for this experiment. We measured the empty flask, and then we measured the flask filled with water, and these two measurements are going to be used to calculate the volume of the flask, and we will use the density of water at 20 degrees, because this is the temperature in the lab right now. We also measured the mass of the foil, the flask, the foil, and the rubber band. And then we also, at the end of the experiment, we measured the same flask, same foil, same rubber band, and this time with the condensed vapor. And so these two masses here will allow us to calculate the mass of the vapor, which of course is the mass of the gas that was in the flask, using the ideal gas law. We will have the volume of the container, the volume of the gas. We have the mass, the atmospheric pressure in the lab today is 102.2 kilopascal. So using that, we can, and the temperature of the boiling water also at 101.7 degrees. So the temperature of the boiling water, the flask was put inside the boiling water and left there for 5 minutes. And the reason for that is so that we can assume that the temperature of the gas in the flask is the same as the temperature of the boiling water. So we have the temperature of the gas, we have the pressure, we have the volume, and of course the ideal gas law constant. So we can calculate the number of moles of gas that was in the flask. Once we have done that calculation, we can use the mass of the condensed vapor, which is the mass of the gas, and we can determine the molar mass by doing grams per mole and then identify our unknown. So now for the calculations. The first question is asking us to determine the volume of the flask. So the volume of the flask, to do that, we're going to take the volume of the flask filled with water and we're going to subtract the mass of the empty flask. So this gives us 159 grams, which is the mass of the water that was in the flask. Using the density of water at 20 degrees, 0.9982, we can determine the volume of water that was in the flask, which of course is the volume of the flask. So 159.3 milliliters. Now to do our calculation using the ideal gas law, we need that number to be in liters. So we will divide that by 1,000. And so we get 0.1593 as a volume of the flask, or the volume of the gas in liters. Next, we're going to find the mass of the gas that was in the flask. And we do that by measuring the mass of the condensed vapor, the little droplets of liquid that were in there. So the flask with the rubber band, the foil, and the vapor was 95.97. Without the vapor, so at the beginning of the experiment, just the empty flask, foil, and rubber band were 95.77. So that gives us 0.20 grams of gas. Using that information, we can calculate the number of moles using the ideal gas law. The number of moles is equal to the pressure, and now the pressure, 102.2 kilopascal in the lab today, divided by 101.325 gives us 1.0086 atmospheres of pressure. So we need to have this pressure in atmosphere because our R value is in liters atmosphere, right? Which is why we need the pressure in atmosphere, and we also need the volume in liters. Our temperature needs to be in Kelvin, again, to match the constant. The lab temperature, the boiling water temperature was 101.7 Celsius. So 101.7 plus 273 gives us the temperature in Kelvin. Now, of course, as we said earlier, we're assuming that the temperature of the gas inside the flask is the same as the temperature of the boiling water. And it should be because we left it there for 5 minutes. This gives us a 0.005227 moles of gas in the flask. We can then calculate the molar mass by taking the mass and dividing it by the number of moles. Again, the mass of the vapor is 0.2, and the number of moles is 0.05227. So grams per mole, 38.26 grams per mole, and that is the molar mass of our unknown volatile liquid. All we have left to do is look at the list of unknowns that we were given at the beginning of the activity and find which one is the closest. Now, because I'm the one that gave out the unknowns, I know that the unknown that was tested was methanol, and the molar mass of methanol is 32.026 grams per mole. So 32.026 minus 38.26. So we are quite a bit off, 6.2 grams divided by 32.026 to get a percentage. 19% error on this one. Probably not our greatest experiment, but at least it gives us an idea. So we have a value of 38.26. Again, it should really be two significant figures, right? Because we have our mass value is 20, so only two significant figures. So we have 38 grams per mole, and we should have gotten 32 grams per mole. So we're over, and it probably is because the foil might not have been completely dry. Maybe there was some water from the water bath. When we cool down the flask in the water bath, the foil probably got wet, which would increase the mass. And if the mass is increased due to the presence of water, so this 0.2 grams is really not the mass of the vapor, but it's vapor plus water, right? So this added water made this mass bigger, and if this mass is bigger, then of course the molar mass will be bigger. So this could be a source of error. I hope your lab was maybe better than mine. Take care.